Hello guys, welcome to today's video, and in today's video we are going to finish the principal properties that we haven't discussed in the last lecture. Okay, so in our last session, if you remember, uh, we did some of the important principal properties of logarithm. Okay, and few were left that day, so we are going to discuss this. We are going to discuss it today. Okay, so today we will start with the very important property, and we call it base changing base changing theorem. Okay, it is also known as base changing property, or it is also known as base change rule. So whatever you see, the meaning is the same. Okay, and uh, the base changing theorem, it says, what does it says? It says that the ratio of the logarithm of two numbers is independent of their common base. This is very, 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 very important property. Okay, so it says that if you take the ratio of the logarithm of two numbers, then it's going to be independent of their common base. Okay, so see here what it means. First, it says that the ratio of logarithm of two numbers is independent of the common base. Okay, so if you take the ratio, see here, what does it mean? For example, here I have log uh, 5 by log 2. Here 2 is equal to log 5 base 4 by log 2 base 4 is equal to log 5 base 5 by log 2 base 5 is equal to, all right, okay, or is equal to log 5 base 6 by log 2 base 6. Okay, so it means that the ratio of the logarithm of any two numbers is independent of their common base. So these all are going to be the same. It is independent of the common base, means that the common base is not going to play any major role in evaluating the value. Understand? Okay, so that's what it means. Okay, this is very, very, very important property. Okay, so here you can see that log of 5 to the base 2 by log of 2 to the base 2 is same as log of 5 to the base 4 by log of 2 to the base 4, right? So what does it mean? It means that the common base does not play any major role in evaluating the value of the ratio of the logarithm of two numbers. Okay, so keep this thing in your mind. Okay, and this property is summarized as, okay, so this property is summarized as this property is summarized as, let me use green. This property is summarized as log m to the base a by log n to the base a equals log m to the base n. So this is your base changing theorem. Okay, this is changing theorem, or base changing rule, or base changing property. Okay, so now this is the property. Now we have to show the proof, right? If this property holds true or not. So we have to work on the proof part, right? So here, let's start with the proof. Okay. So what I will do here, I will just take this part. Okay. Let's say that I'm taking this right hand side, and I'm just saying that let's assume that that log m to the base n is equal x. This is my assumption. Okay, so from this assumption, because see here, this is here, I have assumed that this logarithmic function is equal to x. So at the same time, I can say that, which implies that n of x is equal to m. Why? Because I'm changing this logarithmic function to the exponential function, right? So it says that n raised to the exponent x equals m. Okay, now if these two numbers are equal, then their logs are also going to be equal, right? Because it's a property. When two numbers are equal, then their logs are going to be equal, right? So here, taking log both sides, what would you get? It implies log of n raised to exponent x equals log m, right? And here we can take the base as a. We can take the base as a. Okay, so uh, now from here, if you see this side, log n raised to x, so we did one of the property, and the property says that log of x to the base a and x raised to power n is equal n times log x to the base a. So we are going to use the same property here. It's going to be x log n equals log m, right? So now what I will do here, I will bring this thing here, okay, which implies x equals log m to the base a by log n to the base a, right? And what is x? On putting the value of x, on putting the value of x, what we will get? Log m to the base n equals log m to the base a by log n to the base a. So that's what base changing theorem, or base changing property, or base changing rule states. Okay, so that's the proof part. Okay, I hope it's visible to you. Okay, you can just have a look, and then we'll move to the next one. Okay, so a base changing theorem, this property is very useful, because by using this property, you can change the base. Okay, now one thing very important here is that when we define this property here, don't forget that m and n must be greater than 0, and a m must be greater than a and n. Okay, a and base n must be greater than 0. A should not be equal to 1 and n should not be equal to 1. Okay, so because your base must be greater than 0 and base cannot be equal to 1, and the number, okay, because log is defined for the positive number, so your number must be greater than 0. Okay, so this is very important property, because this property is used to change the base. Okay, and here your base can take any arbitrary value, right? But make sure that the value should not be equal to 1. Okay, so this theorem is going to be very, very important. Okay, now let's move to the next property and see what it says. Okay, so the next property is also based on the base changing theorem, and we will have a look at what it says. Okay, so property number 2 that we are going to discuss now, uh, it's it is next property, property 2. Okay, property 2 for today. So it says that this property is basically the implementation of base changing rule. Okay, what does it says? It says that log of b to the base a is equal to 1 by log of a to the base b. Okay, so this is the property. Okay, now this property is the implementation of base changing theorem. Okay, now this is the property. Now we have to work on its proof. Okay, so let's switch to the proof part. So here in proof, let's take I'm going to take this side. Okay, a log of b to the base a. Now what I will do here is that I am, now see here, this is log of b to the base a, which is the left hand side of this property. Now here, I'm just going to change the base. Okay, I'm just going to change the base. Or what I can do is, won't you mind if I write here log of b to the base a multiply log of a to the base b equals 1. Okay, so I did nothing. i just I just transferred this thing here, right? Now what I will do, applying the base changing theorem, what would happen now? Uh, if you apply this BCT, base changing theorem, on the left hand side, so it's going to be log of b to the base k by log of a to the base k multiply by log of a to the base k divided by log of b to the base k, right? And and uh, if you see here this will get cancelled with this will get cancelled with this, so it's going to give you 1, and that's what it says here. Okay, so it means this property is true. So remember that log of b to the base a, it is equal to 1 by log of a to the base b. Okay, means that if you have to change the number and base, then it's going to be the reciprocal. Okay, this property is going to be very, very important. Okay, now just have a look at it, and then we will switch to the next property. Okay, so our next property says that our next property says our next property says our next property sorry property number 3, it says that a raised to the exponent log c base b is equal to c raised to the exponent log a base b. Okay, so this is your property number 3, and this property is also known as the exchange property. Exchange property. Okay, now see here what's happening here. Okay, a raised to the power or exponent log c base b is equal to c raised to the exponent log a base b. So what's happening here? So these are just exchanging. A is taking the place of c, and c is taking the place of a. Understand? So this is the exchange property. Again, very important property. Okay, so just see its proof. Okay, so let's work on its proof. So we'll start with this: a raised to the exponent log c base b. Okay, now this is our left hand side. Okay, now if we are going to change its base by applying the base changing theorem, what would happen? Here would be a, and here log c base a by log a base b, right? Here you can say applying the base changing theorem. Okay, base changing theorem. Now this is be careful here. See here, this thing is, can I write here a, and here log c to the base a multiply by 1 over log a to the base b? Yes or no? Yes. Okay, so this thing is raised to the power. Okay, now this log a to the base b, it can be written as here, it can be written as log c to the base a, and this can be written as log of a to the base, sorry, log of b to the base a, b to the base a. Why? See here what I have applied. I said that 1 by log of a to the base b is equal to log of b to the base a. This is what I have applied here in this part, right? So now now this thing, if you see here, log of b to the base a, so it's going to be, sorry, what is it, c here, c to the base a, and here b to the base a. Sorry, this is b to the base a. b to the base a. This is b to the base a. Oh, that's a mistake. B to the base a. This is b to the base a. So it's going to be a to the base b. A to the base b. So here it's going to be a to the base b, right? Yes, a to the base b. Now, this thing is a log ac. It's going to be c, right? It's going to be c. So it's going to be c log a to the base b. Why? Because see here what we have used here, a log c to the base a is c, right? Because you remember this property, we have done this property. It says that a raised to the exponent log b to the base a is equal to b. Okay, so it will take the value of c. So that's why a raised to the exponent log c to the base b is equal to this. This is very important rule. Just make sure that it stays in your head for long. Okay, so they are just interchanging their place. Okay, so now go to the last one. This is exchange property. Go to the last one. Now the last one is the last one is the last one is our base power property. Okay, base power property, property number 4 is going to be base power property or base power rule. And what does it says? It says that log of b to the base a raised to power k or exponent k, it is going to be 1 by k log b a. Okay, so last time in the previous session we did one property and it was power rule, right, which says that log of x raised to the exponent n is n log x. But what happens when your base is raised to some power? Then it's going to be 1 by k log b to the base a. Okay, now see here, you may, now what happened, it may be possible that the base is raised to the power and the number is also raised to the power. For example, log of b to the base n, and here a to the base k base. So what it's going to be, n by k log b to the base a. So there should be no problem. Okay, let's work on the proof part of this. So let's take let's take this side, b to the base a raised to k. Okay, so if you apply base changing theorem here, so it's going to be log b to the base k by log of ak, and here k to the base k, right? So what can be done here? Sorry, log a, okay, with respect to a. Okay, so this log, this thing can be written as log b to the base a by here this comes outside k, and here log of a to the base a. Okay, and now if you see here log of a to the base a, this thing is 1, right? So it's going to be 1 by k log of b to the base a, okay, which is log of b to the base a raised to k. So this is the proof. That's how you have to do it. Again, very important property. So today we did the 4 properties. The first is base changing theorem, which says that log of m to the base n, it's equal to log of m to the base a by log of n to the base a, means that the ratio of logarithm of any two number, it is independent of their common base. Then property number 2 that we did, it was property number 2 that we did, it was the implementation of BCT, which says that log of b to the base a, it's going to be the reciprocal, and it's going to be 1 by log of a to the base b. Okay, then number 3 property that we did, it was just the exchange property, which says that a raised to log of c to the base b is equal to c raised to the exponent log of a to the base b. Okay, and then number 4 is this one. It is a base power property, and it says that if your base is raised to the power, then in the form of a raised to power k, then this will come outside 1 by k log of b to the base a. Okay, so that's all. And in next session, we are going to work on the questions based on this property. Okay, so we'll see you next time. Thank you.